Okay, so in this video we are going to look at Gephi and its features, what kind of analysis we can do with Gephi, and how we can even import network data from other sources and analyze them in Gephi and all these things. So to get Gephi installed on a computer, just go to Google and search for it. Okay, and that should get you to this page. So in this page you can see that there's a free download software option available. Just download and install it. So I have already installed Gephi in my computer. So what I'm going to show first is how to load a network data, because you cannot generate any network data in Gephi. You have to load it from an external, have to collect the data from an external source and then load it into Gephi and visualize it. So I'm going to show you how to do that. So what we'll do is we'll use CINET. In the previous video I have generated a random network of 20 vertices, and the probability of an edge between any two vertices is 0.5 for this random network. So I'm going to copy this, and I'm going to show different sources of collecting the network data. And CINET is one way of collecting the network data, which we saw in the earlier video. So I'm going to go to Excel and just paste this. This is as I said, is an edge information. This says that there's an edge from node 0 to node 1, and the last two columns are basically not informative for us. So I'm first going to split this into 4 columns, because right now when I paste this in Excel, it's all showing up as one column. So I'm going to split it into 4 columns using this delimiter, which is space. So I'm going to continue, and space is already here. So now it is split into 4 columns. Now we can discard these 2 columns. So this is an edge file. So I'm going to label these columns. Gephi specifically requires the columns to be labeled as source and target. Okay, and this is a directed graph. There's an edge from 0 to 1 and there's an edge from 1 to 0. Now I'm going to save this as a comma delimited file, which is basically a CSV file. Okay, in Excel. I'm going to label this as this is an edge set, right? So this is my edge set. Okay, and initially it will say the format will get affected and all these things. Don't worry about it. Say OK and click yes. And we know that there are 20 vertices, right? So 0 to 19. So we have to label, just say yes and no compliance format, OK, yes. Okay, let me, there was something let me just delete that node set file which I was doing something. Okay, alright, so now we created the edge set file, and I said there are 20 vertices. So I'm going to create just something like this, telling this is like ID stands for node ID, and I'm just going to type those numbers. You can also automate it by saying this is A8 plus 1, which is 7. Okay, 7 plus 1 is 8, and you can just copy and paste like that, and that will create you your 20 vertices. We need one more. Okay, so this is my node list. So I need to save this again as a CSV file. Okay, so this is going to be my random network node set. You could name it anything you want, but it should be a CSV file. Don't worry about the compliance, just say OK and yes, and you can close it, and you can just again say yes, OK, yes again. So now let's go to Gephi. If you just open Gephi, it will, let me show you how to do that. Let me close it. So once you install Gephi and open it, so it will give you whether you want to open something that you have done recently or open a new project or graph file and all this stuff. So I'm going to just say new project and it will come back to this. And now let's go to data laboratory, and this is where I'm going to select import my CSV file first for the nodes. So I click on this and make sure you select nodes table and click on this. Sometimes this is a GUI Java applet based thing, so sometimes the icons won't show up, but you can go back and select your node set. So these are your 20 vertices, and if there's any problem it will say an error, but everything is fine with this CSV file. So make sure you label the column as ID, and it will ask you how to import it, whether the ID as a string and all these things. You could just say okay, and this is now your nodes. Okay, now go to edges, click on import spreadsheet. Now you want to import your edges, click on that, and want to make sure you select edge table. So this is now the source and target edges, vertices of each edge. And how you want to specify those, you can just specify a string, and then you can see the weight by default has been selected as 1 for each edge. So these are your nodes and edges. Now click on overview. So this is a graph for you. Okay, so you can analyze the different options, features that you have inside Gephi. So basically, if you want to zoom this, you can click on the icon here and you'll get different things that you can zoom. So global, so if you want to zoom this, you can move this to the left, move this bar to the left, and you can keep zooming it. Okay, and you can even now, okay, if you close this it will go out, and if you can label the vertices, because you already have a ID. Actually we have not labeled it yet, right? So if you look at the data laboratory, the label column is empty. So if you want the numbers or whatever the name you want for each of these nodes to be displayed along with this figure, you have to label the vertices. So in this case, let's say I just want to label them as label the vertices as based on the ID itself. So what I can do is you could label it anything you want, because in real networks each of these nodes could indicate different things like countries and all this stuff, but here I just want to label the vertices with the ID itself. So I could go to, so make sure you are under nodes and not under edges, because you don't want to label the edges, you want to label the nodes. So go to nodes and you can see the label column, because Gephi automatically creates a label column for your vertices, and you can copy. So there are different options here, so make sure you can, sometimes this goes down and you cannot see all the options, so you can reduce the size of the Gephi window and see the different things that are available in the bottom. And for the, you want to copy the data to another column, right? So you want to copy data from ID, so select this. So copy data to other column, select this, select ID, and copy data from ID to copy to label. That's the only thing that is not yet filled up, so that's the label. So now you have the vertices, the labels for the vertices. So now if you go back to your overview, you see Since I already selected the label thing, but no label was assigned to the vertices, but now I have already assigned, now I have assigned the labels to the vertices, the labels also get displayed. Okay, so now you can see this is a random graph, so there's no supposed to be any particular node with a high degree. Almost all the nodes should have some comparable degrees, and that is how it looks like. There's no hub a graph where one node has a high degree. So almost all vertices have comparable degrees, and we can even visualize that. And before visualizing it, let's look at some statistics that are available in Gephi. So here it shows some statistics that you can measure for your network, and these are the built-in measures, statistics that you can measure. Of course, you can see it does not have everything that you saw in class. For example, like in CINET, we can do betweenness, centrality, and all those things, which is not here. So this is one one weakness in Gephi, because Gephi cannot analyze the different measures, whereas CINET can analyze for you several measures, which you saw there. Okay. But of course, we are going to get around it in another video. I'm going to show you how you can measure something in CINET and then load that here in Gephi and visualize those measures also. So let's click on run. So if I click on run, I see a distribution of the degrees like this. This is a graph of 20 vertices with a probability of 0.5 for the edge between any two vertices. So that means we'll later look at the random graph model. The average degree is actually n times p, the number of vertices and the probability of an edge between any two vertices. So the number of vertices in this graph is 20, and the probability of an edge between any two vertices is 0.5. So you're expecting a degree of 10, and that's what we also see here. Okay, and this is a pretty smooth distribution of the degree. Now if you want to also calculate, say, the hits thing, so that will give you the hub and authority score. It gives you an option of whether you want to make this as a directed graph or an undirected graph. This is a directed graph for us, so let's go ahead and make it directed. So this is a distribution of the hub scores and authority scores. So you can see this displays how many vertices have a particular score. So there is one vertex with a particular score, like this score, another vertex with this score, another two vertices with slightly different score, and so on. Okay, it's not that informative in Gephi. Okay, and that's another thing. CINET, we can look at the numbers, what is the centrality for each of the nodes, but in Gephi we cannot look at the centrality or any of the scores. But get around it, you can go to the data laboratory and look at those scores actually. So here you can go to the IDs. Okay, so this is like the in degree, out degree. Actually, this is viewed as a directed graph if there is, but if there's an edge from 0 to 1, there is an edge from 1 to 0. Okay, so that way it is an undirected graph in one sense. Okay, alright, so the authority scores are displayed here. So these are the different, and it is a normalized score as we saw in class. You can normalize authority score and hub score. So this is the normalized hub score of the 20 vertices, and this is the normalized hub score of the vertices. Okay, so there is actually we don't need this degree, because since it is loaded as a directed graph, it adds up the in degree and out degree. But we know that there cannot be a degree of 22 when you have only 20 vertices. So that is something Gephi has to fix. Once it finds out that it is a directed graph, but it assigns them in degree, out degree, and the overall degree is sum of the in degree and out degree. But in this case it is an undirected graph treated as a directed graph. Okay, so so we can delete this degree column and just stay with in degree and out degree, because this is an undirected graph. Okay, or we will just not use it, so you can delete it, or let's just not use it. So as you see, if I keep clicking on the columns, I can sort the vertices based on, because this is a string, so that's why it is sorted like this. But if you want to sort them based on in degrees, okay, you can go back and come back to data laboratory. It will be sorted based on, again, in alphabetical order. So okay, all right. So each tool has its own glitches, so nothing is perfect. As this is an evolving field, it makes sense. So let's so we already ran it, but let's run it and again, and okay, so that's the hits algorithm run. So now let's say I want to go one step further. You see all the vertices here are shown with the same node size and same color and all these things, right? So I want to go one step further and create the vertices with different node sizes and colors. I can do that using this ranking option, and let's see. Actually, before doing that, let's choose a layout. This looks a pretty decent layout for our graph, but we can play with different layouts here that Gephi provides. I can choose this Force Atlas 2, that's very common, and you can see it tries to see what's the best way to present the network, but what we had before is good enough. Okay, you can stop it. And another glitch that Gephi has is, once you choose a layout, you cannot get back to the previous layout or the original layout that got loaded for your graph. You have to just try the other layouts that are out there. I could not find a way to get back the previous layout, but typically if Force Atlas 2 does not give a good layout, I try this Frucherman Ringgold layout. They are probably two different layout algorithms. So if one doesn't give a very good layout, the other gives you typically. Or if it's still running, tries to give you a better one, so you can stop it, then it stops with that. The other layout that is commonly used is the Wi-Fi Who. So these are three typical layouts that you can try and see. You can try any of those layouts and see which layout gives you a good view of your network. This is good enough for this. Okay, so if you again try to run it, it won't show you any different because it's already there. This is the best possible view of this network under this layout. Okay, so now I want to go to my ranking option and rank the nodes, say based on degree. So actually I want to size the nodes based on the degree. So nodes with a larger degree, I wanted them to appear big, and nodes with a smaller degree, I want them to appear small in terms of node size. So I can actually there are two options. This is actually the color option. If you place your mouse on the top, it will show you that. This is the size weight option, so I have to choose that, and once you select that, click on degree, and you could these are the node sizes. You could run it, and you can see now the nodes are now sized differently. The larger degree nodes have the larger circle for the node, and the smaller ones have smaller circle. Okay, so you can even preview this. If it doesn't show up after click on preview here, you click on refresh here, you can see the different vertices. So this is your Frucherman green gold layout. Okay, so this was a smaller vertex there with a smaller node size. This is larger vertex that we saw here. Actually, if you don't want to look at this, the curvy shape is typically looking good. If you don't want curve, you can unselect this and you can refresh this, but curved layout are typically good. Okay, and let's do one more change or one more feature. So we just had node sizes based on degree. We have other metric that we just measure, which is the hits thing, like the authority scores. That's what we typically use. So we could use that for another thing, the size. We can vary now the colors of the vertices based on the authority scores. I would leave it to you as practice, but we could use also the clustering coefficient as a measure for the colors. So let's do that, because clustering coefficient and degree typically don't go together. So I am running the clustering coefficient thing. Actually, yeah, so the average clustering coefficient comes out to be 0.54. That's reasonably good. So now let's go back and use, because you have to run those metrics here in order to use them here for your ranking. So now I have run the clustering coefficient. I'm going to use that. So go back to your color option and open it up. So you see now clustering coefficient has come up. Previously it was not there because I have not run it until now. So now I have run it, so it shows up here. So select the clustering coefficient option. Now we can color the vertices. Again, the range of colors that CINET showed you, but typically I select the light white, plain white, light white to dark black, like this. Okay, so which means the nodes with the larger clustering coefficient will be darker. Okay, and nodes with a smaller clustering coefficient or relatively smaller cluster coefficient will be lighter in color. Okay, so let's apply this. So now you see nodes with a relatively larger clustering coefficient are darker, like this guy, and nodes with relatively smaller clustering coefficient are lighter in color. So this one, it has a high degree, but it has low clustering coefficient. You can also see when I place my mouse on this node, it displays you just some selected vertices connected to 12. Basically, those are the vertices that are connected to 12, not selected actually all the vertices that are connected to 12, but it does not display the other vertices which are not connected to 12, right? So so if I place it on any vertex, right, these are the vertices that are connected to 11, right? Now if you want to see those edges little darker, you can come open the option here and go to edges, and you can increase the scale, so this will darken them. Now you can see start seeing the directions for your edges, right? So that's good enough. So now if I place my cursor here, I can look at for vertex 11, what are the edges connected to it. And this is actually, as I said, this is an undirected graph loaded as a directed graph. Okay, so you can play with how to load the graphs, okay, either directed or undirected depending on how it is. Okay, so you can preview it too. So you have to refresh it each time you make a change and you want to preview. Make sure you refresh it. So now you can see the vertices. This node has very high degree because the degrees are based on node sizes, but it has low clustering coefficient. Whereas this node has relatively lower degree because the size of the circle is smaller compared to the other big ones here, but it has very high clustering coefficient. So this is something that we typically see as a kind of a trade-off between degree and clustering coefficient, because if a vertex has very high degree, all its neighbors need not be connected to one another. It's very difficult to connect all your neighbors to one another if you have very high degree, right? So that's why if a vertex has high degree, it's more likely to have a low clustering coefficient. On the other hand, if you have only two neighbors, they could be connected to each other. Okay. This one has relatively low degree, because I think it's connected to 3 or 4 of these vertices, and it has low clustering coefficient too. Okay, so that's the thing you can have. So again, when you go to the data laboratory, since you already also have clustering coefficient, you can rank the vertices. So just click on that, you will see the ranking of the vertices based on the clustering coefficient, and this is from smaller to larger. If you again click on that, it will get you from larger to smaller. So node 5 has the largest clustering coefficient, and you can go back to overview and see where node 5 is. Node 5 is probably this one. Yeah, so this one has the largest clustering coefficient, but its degree is quite small. As you can see, its degree is like 11. No, sorry, its degree is like 8. Okay, so it has 8 vertices connected to it, but the largest degree is 14, and for that node the clustering coefficient is not that bad, it's 0.5 or above. Okay, and remember, this is a random graph too. Okay, so if you have, for a random graph, there is likely to be an edge between any two vertices with a certain probability. There's no preferential attachment as in the other models, so this is okay for a random graph. Okay, so we'll stop with this. So in this video, we basically saw how to load a random network into Gephi and analyze the properties. In another video, we are going to see a more hub and spoke kind of network, not like a randomly distributed network like this, and we'll look at how to we'll look at the properties of that network. Okay.